Hello everybody, my name is Jonathan Tebow and today we'll be going over Module 8, specifically work. So what is work? Work is just the energy within a system, and when we're talking about system, we're talking about gases, right? Gases. So work is equal to negative pressure, delta V, or negative PEV, whatever you need to do to memorize this, right? So let's break this down. There are a couple new things that you haven't noticed. Probably this delta is the first time you're seeing this. That just means change in. So change in volume. The way we calculate that is just final minus initial. Also take note of this negative sign. And those are probably the most important parts of this. So let's talk about units. Volume is measured in liters. Pressure is measured in atmospheres. So work has two units actually, right? It's got that liter atmosphere relationship. And because it's energy, we can also use joules. There's a relationship between liters, atmospheres, and joules. They are not interchangeable, so you will have to convert from liter atmospheres to joules, and that's a 1 to 101.325 ratio. Right, so just use that in the dimensional analysis and you should be good. So let's break down this work equation into negative P delta V. Remember that we said delta V is just V final minus V initial, and I'm just using F and I. So these are two variants of the work relationship or the work formula. If you use either one of them, it's fine. Just as long as you don't forget that negative and you don't forget that delta. Okay, cool. So let's remind ourselves once more of this work equation. Work is negative P delta V. So if work is positive, right? Because work can be either positive or negative. Let's start off with a positive portion. Work is positive, work is done on the system, the gas gains energy, right? So how does work become positive? Well, if pressure is negative, then that means delta V, final minus initial, must be negative as well. The only way it can be negative is if the initial is higher, right? So that means V gets smaller or it gets compressed. Now that's a word we like to use, compressed. And then same thing for if work is negative. If work is negative, then work is done by the system. The gas loses energy. Also, it gets expanded, right? And that's a word we like to use, expanded, because that means the final volume is bigger than the initial volume, right? And there is one last thing that we like to talk about, and this is vacuum conditions. Because in vacuum conditions, the pressure is equal to 0 atmospheres, right? And if something is equal to 0 and it is multiplied, right? So this could be any number, right? So if it is 0, then that means the work is immediately 0. Make sense? And that also means that the change in V does not matter because there is no pressure to be multiplied against. So if pressure is 0, work is also 0, and change of volume does not matter. So let's go over a problem. If you're able to get this problem, then you've mastered this because this is an all-encompassing problem. So 2.5 liters of gas was heated up from 20 degrees Celsius to 200 degrees Celsius at a constant pressure of 1.75 atm. Find work done in joules, right? So let's write down what we know. We have an initial volume of 2.5 liters. We don't know what our volume final is, so let's put that as x. We know that our temperature initially was 20 and our temperature final was 200. Pressure is constant at 1.75. And then finally, we want our answers in joules. Okay, so we don't know our volume final, but we do know this is a gas, right? So gas laws still apply. So we can set up a proportion to find our volume final, and that's 2.5 over temperature. But remember that we cannot use Celsius, right? And this is Celsius. Can't use Celsius within gas laws. We have to convert that into Kelvin. And the way we do that is you add 293, or 273, I'm sorry, and you get 293 and 473 Kelvin, right? You just add 273 to Fahrenheit to get Kelvin. Something you need to know. Now we have something we can finally input here. And so that's going to be 2.5 over 293 is equal to x over 473. And then you just multiply that way and then divide that way. And then we get a final volume of 4.036 liters. Right, if you want to do the calculations by yourself, just pause the video. I highly suggest that you do. Okay, but we have our volume final, and finally we can use our work equation. Remember, that's negative P delta V, or the one I'm going to use is the other one, which is work is equal to negative P V final minus V initial. And then we'll just plug all of those things together. So that's work is equal to negative 1.75, and then V final is 4.036 minus 2.5. We'll multiply that all together, and then we get negative 2.68 liter atmospheres, right? But remember, our question is asking us in joules, so let's convert that. You got negative 2.68 liter atmospheres, and 1 liter atmosphere equal to 101.325 joules, right? And so when we multiply that all together, we get a final answer of negative 272.33 joules. So that is the number of amounts of work that is done on the system or by the system, right? Is it on or by the system? Well, if it's negative, then it's by the system, in order to convert this moles of gas when heated up. Okay, so that concludes my lesson on work.